In this lecture, I will go through a complete OpenGL program including the shaders that will display a white square on a black background. A complete OpenGL program has three files at the minimum: the main program, a vertex shader, and a fragment shader. Let's start with the main program, which is a CPP file named simple. Simple.cpp is spread across 3 slides and has 3 functions: initialization, display, and the main function. We include angel.h, which also imports the required OpenGL libraries. Angel.h comes with the textbook. We write using namespace std to avoid having to write : every time we use a variable defined in std. Next, we define 2 constants. The number of triangles, which is 2 because we need 2 triangles to make a square. We will study later why a triangle is a preferred building block in computer graphics. The second variable is the number of vertices, which are 3 times the number of triangles. Next, we define an array of points where each point is of type vec3, which is also defined in angel.h, and there are num vertices points in the array. We also initialize the array with the 3D coordinates of the 4 corners of the square. Note that we set the third dimension to 0. Since we need a flat square. This is an example of how 2D graphics is just a special case of 3D graphics. Now we are ready to write our init function. Inside the init function, we create a vertex array object. In OpenGL, creating an object follows 3 steps. Define a variable name, which is type GL unsigned integer, Define the object that the variable name refers to, which is the vertex array object, and then bind the object with GL bind vertex array. Using similar steps, we create a buffer object. Notice that the variable name GL unsigned integer is again used for the buffer. The name buffer itself is chosen by us and does not tell OpenGL that this is a buffer object. It is in fact the next step where we specify that this is actually a buffer object. In the third line, we bind the buffer to OpenGL array. Notice that we are using the reference symbol, the AND symbol here. It is recommended that you refresh your knowledge of pointers and references in C++ to better understand their use in the context of OpenGL programming. Also remember that OpenGL is a state machine. At times it might feel that a certain object was created but never used. That object was in fact the current state and hence implicitly used. You can think of this as a set of instructions such as pick a blue marker, open page 5 in your drawing book, draw a circle. Now, was the blue color used or not? After creating a buffer object, we use the glBufferData function to create a buffer of the size that we need to hold the actual data, the 6 points. Here we pass the size of the points and the pointer to the points and select static draw. Now we are ready to specify or load the shader programs we want to use. We will write these programs later and call them vertex.glsl and fragment.glsl. The GLSL extension stands for OpenGL Shader Language, and the names vertex and fragment were chosen by us, and it is their order that tells OpenGL that the first one is the vertex shader and the next one is the fragment shader, and not their actual names. We could have chosen other names. Init shader compiles these shader programs, and we can reference them with a GL unsigned integer variable program. We pass program to OpenGL and tell it to use this program for shading. Now initialize and pass on the 6 vertex positions to the vertex shader as attributes in the last 3 lines. The name vPosition will appear again in the vertex.glsl program. We enable the vertex attribute array here and the vertex attribute pointer here. GL float tells that the vertex positions are of type float. GL false means that the data does not need normalization. 0 basically means that there is 0 stride in the data, that every point has to be drawn, and we want to draw from the start, and hence there is no offset. The final line, GL clear color, sets our background to 000 RGB values, which is black, and also set this opacity to 0. After initialization, we are ready to define our display function, which is rather simple in this case. We clear the buffer, then 10 OpenGL to draw the arrays as triangles, starting from the first index and drawing all 6 vertices. GL flush tells OpenGL to draw it now and to flush the buffers. Now, getting to the main function. We use glut init to initialize glut, and then we define or initialize the display mode as glut RGBA. RGB are the three color values. A is for opacity, and we're using this variable from glut library. Then we set the window size to 256 by 256, and then finally we create the window and name it as simple. Simple will appear on top of the window so we can identify it. In fact, we can have multiple windows, but for now let's stick with one window. Here we call the initialization function that will define all the vertices and the objects. Next, we define our display callback function. This display name is the same as this display function name. We could have chosen another name here, but this should match this. Then we put the main function in an infinite event loop. The event loop basically checks if anything has happened that requires redrawing the window, and if an event happens such as moving the window, it will call the display function again, and the display function will redraw the contents of the window. This slide shows the vertex shader program, which has one definition and a main function with one line of code. Remember that this is a very specialized OpenGL shader language, and with some practice you'll get the hang of it. vPosition is defined as an attribute of type vec4, which is defined in angel.h. This name, vPosition, must match the name chosen in simple.cpp get attribute location function. GL position is an inbuilt function in GLSL that holds the vertex positions. The fragment shader simply defines the color in which the fragments are to be drawn. GL frag color is an inbuilt variable in GLSL. Now if we compile simple.cpp and run it, it will display a white square on a black background. This seems to be too much code for a simple drawing, but a lot of that code is for initializing various objects and buffers and setting the background and foreground color.